Hi friends, it's Kamal and you are watching Maths by Jajoria. Please don't forget to subscribe my channel. In this video, I will explain differentiation. It's a new topic, and before I start that, I hope you enjoyed your summer holidays and got your new classes and upgraded one. So probably have the new syllabus now. So let's work on that. So differentiation. Before I explain the differentiation, I will just give a touch on gradients of curves and followed by finding the derivatives and if possible in this video I will go with the differentiating quadratics. If not, then it will be the next video. This video gonna be approximately 1 hour because there's a lot to discuss. So I hope you're okay with that. So let's start with that. The gradients of curve we start with. The gradient of curve is constantly changing. Now, some of you, if you haven't watched my previous video on gradients, I have explained gradients, and if possible, please watch that. I will leave a link as well in the description box. So I hope that okay. So I would really recommend you to watch that first before moving on to the differentiation. Okay, so let's start again. So gradients of curves. The gradient of curve is constantly changing. Now, what you have studied before, that you had one gradient of the curve. So we discuss a lot on that one. However, in differentiation, in calculus, I should say, in calculus, when you study differentiation, you would see that the gradient is moving frequently because that you will see what I'm trying to say here. So that's why you see here is the gradients, not one. So gradients of the curve. It's just to find the values. So let's go with that again. The gradient of curve is constantly changing. So what it's trying to say here, the curve will be constantly change. Okay, so this is what it's trying to say here. And you can use a tangent to find a gradient of a curve at any point on the curve. So that's we have discussed that previously. So that's a similar thing. A tangent to a curve at a point A is the straight line that just touches the curve at A. So I have this here. So I'll go through this graph first, and let me just give this name here as well. So you got X and Y here, okay, and that's 0. Okay, that's fine. Right, so let me give this right down here, y equal to x cube minus 2x plus 1. Okay, so that is your curve. Right, now the gradient of a curve at the given point is defined as the gradient of the tangent to the curve at that point. Okay, so in here you see this in red, you see here, so that is your tangent. So tangent to the curve at 1 and 0. So this point here is your 1 and 0. So just write down here for you as well. So 1 and 0. Okay. Okay, so here the tangent to the curve at 1 has the gradient of 1. Okay, so again I would like to say to you that if you haven't watched the previous video, and if you don't really have a good knowledge on gradients, how to find gradients or with the tangent, then please watch my previous video. Okay. However, I will try my best to just give you a very brief on these things before moving to differentiation, because the main topic here is differentiation. Okay. About this here. Okay, so that's the tangent. Okay, let me just write down a bit so that it's clear to you as well. The tangent. Okay, and that's your curve here. Okay. Okay, so it's to the curve is at. Okay, so that's your coordinate. Okay, and this has a gradient 1. Okay, right. So the gradient of the curve at the point this 1 and 0 is equal to 1. Okay, so write down here again. So that is here. So write down again the gradient of the curve. Okay, at point 1 and 0 is equal to 1. Okay, so remember that. Okay, then the tangent just touches the curve here at 1 and 0. It does not cut the curve at the point, although it may cut the curve at another point. So depending on your curve, how the curve goes. So here is touching it, but not necessarily it will touch other side. It can probably what you call cut the curve at another point. So it could be like, say, if you go in this way and if the curve went like this, so it would have been cutting there that side. Okay, so that's just a touch. So just remember these things here. Okay, now the main bit here is this: the gradient of the curve at the given point is defined as the gradient of the tangent to the curve at that point. Okay, so just remember that, please. Okay, now that should be followed by one of the example here and what I'm trying to say to you. So it's very important, so please concentrate on that. Okay, so that's the main part of it. So this diagram here, okay, so this diagram here, okay, it shows the curve with the equation y equal to x squared. Okay, so that's your curve here. Okay, so this curve I'm talking about here. So that is your y equal to x squared. Okay, so remember that. Okay, so maybe I can just write a bit here. The diagram shows that the diagram shows that the curve with equation y equal to x squared. Okay, then you got tangent here in the red, and that is your t. Okay, so the tangent t, so let me just write down here as well. So then you got the tangent t to the curve at the point A. Okay, and that is your 1 x1 and 1. So this 1 and 1 here. Okay, so that is 1 here. So that's A here. You can see. So that point we're talking about. Okay, so it's 1 and 1. Okay, x is 1 and y is 1. So coordinate 1 and 1. So that is, just remember that, please. Okay, is shown here. Okay, now point A is joined to point P. So that's your point P here, and that's your point A. So that's joint. So it's like a chord, yeah. Okay, so joint. So I write down here now. So point A is joined to point P by chord AP. Okay, so then now, because it's inside this curve, so as you know, this will call chord. Okay, so your AP is chord. Okay, and then outside, which is touching, that is your tangent. Okay, and that is your T here, right? Now, also you will see all this coordinates here. Okay, now I will go through some of the examples here, and then we will see that how the gradient will change as we will shift this P to close to A. Okay, and that's what we have to achieve in this example. Okay, when we bring this point P here closer to A, what will be the gradient? Okay, so this is what we need to see, right? So with this, we have to find first the calculate the gradient of tangent A. So I will go here with you, write down here A. So this is here, calculate the gradient of tangent T. Okay, so you need to find you need to find the gradient of tangent T. Okay, so how would you do that? Okay, and pretty simple. Watch my previous video on that one. So to find that, you need to write here. So say, okay, right, so gradient of tangent, that is equal to y2 minus y1, x2 minus x1. Okay, so use this formula. Okay, and as said, you can find that in my previous videos as well. However, so this is the formula. So use of this formula, gradient. So this formula is for the gradient of the straight line between. So I just write down here for you as well. So this formula is the formula for gradient of a straight line. Okay, as your tangent is straight line. Okay, and that would be like when it's between the points. You have x1, y1. Okay, so it's like if you have this line, if there's a 2 points. Okay, so that's what it exactly is, x1 and y1, and then you have x2 and y2. Okay, and if you have this, that is your formula. Okay, so remember that. Right, so let's move on quickly on that one because I want to finish this before I need to move on to differentiation. Okay, so what would we get then? Okay, we will get here 3 minus 1. Okay, 2 and 1. So where do you get the points used here? So the points used here is 1 and 1 and 2 and 3. Okay, so you have 1 and 1 here. Okay, and then you have used 2 and 3. So it's just because the point has been used here, that's why it is you got here the gradient is equal to 2. So okay, so that's what the point will be used to calculate the gradient. Okay, so 1 1 and 2 3. Okay, so that's your 2 and that is your 3. So that doesn't matter. I could have used that one. However, the gradient you will see would have been this. Okay, right. So that's very basic. Okay, let's move on. So calculate. Now what I'm gonna do, we're gonna calculate the gradient of the chord AP. Now we have the gradient here. We have the tangent one. we need to find the gradient of AP actually. Okay, and then chord AP, and when P has a coordinate. So when the P here, P has the coordinate. So what will happen? A, you know the A coordinate. So we're gonna give P coordinates, and then slowly bring that one, try to bring closer to A. The coordinates, bring the coordinates closer to A. Okay, and what we will get. Okay, right. Okay. So let's say if I say to calculate the gradient of the chord AP, and when P has the coordinate. Okay, so just write down here for you. So you calculate the gradient of chord AP when, okay, when P has a coordinate. Okay, when P has a coordinates. All right. Okay, so let's say if you have the coordinate, P has a coordinate 2 and 4. Okay, so let's say the P has a coordinate 2 and 4. Right. So the gradient of the chord joining. So I write down here for you what that would have been. So gradient of chord joining 1 and 1, and as I said, and sorry, not and 2, 1 and 2, coordinate 2, 4, 2 and 4. Okay, so let's finish this one here. So that is your 4 minus 1, 2 minus 1, and that is equal to 3. Okay, so remember this one. So this is your 3. Okay. Right. Let's say if you have find out the gradient of the chord joining joining this. Okay, 1 and 1, 2. So let's say okay, yeah. So here we say another 1. So here you joining 1, 1, 2, 1.5 and 2.25. Okay, so 1.25. So is 1. This one to 1.5 to 2.5. So it's somewhere here. Okay, right. Now you see before we had 2 and 4, that is here. So 2 and 4, it was here. Okay, so now it's coming closer to it. Okay, so what that would be then? So the gradient of the chord joining 1, 1, 2. So what that would be? That would be your 2.25 minus 1, 1.5 minus 1. Okay, and that will give you, that is your 0.5, and if you calculate that, yeah, that will give 2.5. Okay, right. Now so that's your 2.5. Yeah, so you see you moving closer to that one. Okay, and here you know this is here your 2. Now you're going closer to 2.2, here 2, because that's the gradient of a straight line. Okay, this is where we calculated the tangent. Okay, so that was the tangent one. This is the chord one. As we got coming closer to A, you see the gradient is changing and is going very close to 2. Okay, so let's have one more example here. So let's say the gradient of the chord joining this again 2. So let's say find out again the gradient of the chord. So write down here gradient of chord joining 1 and 1. Okay, 2. But this time I will say 1.01 and 1.0201. Okay, because I want to come more closer to that. Okay, now you will see when the point is closer to 1 1 and 1 rather than, so you're very close, 1.01 and 1.02, so you're almost there. Okay, it's a very small distance. Sometimes you know not really easily seeable with your eyes here. Okay, so let's go on that one. That will give us 1. Okay, so let's say 1.0201 minus 1, and then you go 1.01 minus 1. Okay, so calculate that please, and that will give you 0.0201, and that will equal to 2.01. Oh, you see that you're very close to 2 there. Okay, now you see if I, okay, so just from here 2.25 you got 2 here, so you see here you are very close to here, almost I would say you are very close to 2, so you are 2 there, so you're very close to 2 here as you're very approaching towards 8. Okay, so now you probably will ask why I'm doing this. Okay, the reason for that is because you need to comment on is the relationship between these. Okay, it will be very helpful if you understand this. When what's the reason, you will see the reason for that when we talk about differentiation. Then you will understand that why the point was so close to, why I'm bringing the point closer to A. Because in differentiation we will find the gradient of the curve. So you see you have at the moment the gradient here, then because the graph can change any point, the tangent can change any point, so it will be, tangent will be variable all the time because it's moving here or here or here. Therefore it's very important to understand this. Okay, we will talk about one point when we talk about differentiation, and this is where it get difficult to understand the gradient of the tangent where you have 2 points. And in differentiation we will presume we'll go with the 1 point. Okay, and that's why this example is important. Okay, so you see here your hair gradient is 2, right? Now I will go for now a gradient of the chord. So here gradient of the chord. Now this time joining 1 and 1, 2. Rather than I give you anything, I would say this time 1 plus h. So just some distance, okay, and 1 plus h. Let's say the whole square of that one. Okay, so let's say I give you that rather than, sorry, Can you see that? Yeah. So these are the points now. Okay. So rather than giving points, I'm just giving you plus 1 plus h. So h could be anything. It could be a very small amount, small figures. Okay. Small distance. Okay. Right. So h is a constant. Okay. So just remember that, please, in this one. So as you have this, okay, so gradient of the chord joining 1 to 1, 1 and 1 to this coordinate to this coordinate now. So what that will give you? So that will give you 1 plus h square, okay, in bracket, and 1, sorry, please ignore this, and then you got 1 plus h, and that is minus 1. Okay, so calculate this one, please. Okay, I can quickly go for you that, and that will give you 1 plus 2h. Okay, you open this, okay, plus h square, and then you have minus 1. So that is your minus 1, and in here you have 1 plus h minus 1. Okay, so calculate this and condense that to that. That will give us 2h plus h square by h, and then further down that will give us 2 plus h. Okay, so you see 2 plus h. So again, a very small distance, very small. Okay, it's probably is 0.00001, something like that. Okay, go into the thousands of that one, very close to that. So what would you say on that one? So you remember this one, 2 plus h. Okay, and then you have 2.01, then you have here 2.5. Okay, and we started with 3, so we started with here and we coming down here close to that one. Okay, so what would you say the comments on the relationship between your answer to the part these two? So what we done in here A, and then in here B. So here what we will say that so I write down here for you. First, I think I will say it first. Okay, so in here we say as the P, okay, so please listen carefully. As the P gets closer to A, the gradient of AP gets closer to the gradient of the tangent of the okay, let me say again. As P gets closer to A, the gradient of AP, the gradient of the chord AP gets closer to the gradient of the tangent at A. Okay, so that, and so this will get closer to this point, therefore they get closer to tangent. Okay, gradient of the tangent at A. Okay, so that is the relationship between. So please understand this one, it's very important. Okay, now I hope you really understand that. Now I'm gonna move on to the finding the derivatives. Okay, right, so as I say that we're talking about here differentiation. So now going closer to differentiation. Now before I move to differentiation, there's one more topic which I want to clear, okay, and discuss that with you. That is finding the derivatives. Okay, so in finding the derivative, sorry, so you can use the algebra to find the exact gradient of a curve at a given point. Okay, this diagram shows 2 points A and B. So let me just draw that one, and that lie on the curve with the equation y equal to fx. Okay, so let's draw that. Okay, so here, okay, you got this one. So let me draw this curve here first. Okay, so that's your curve. Sorry, just not really kind of straight. Right, now here I will give this here point A, and here I'll give point B, and as it says, the curve with the equation y equal to fx. Okay, so remember this. Now, as point B, so I'm going to give point B here. Okay, that's point. So as point B moves closer to point A, the gradient of chord AB. So let's make the gradient first AB. Okay, that's your AB. So the gradient of chord AB get closer to the gradient of tangent to the curve at A. And this is what we already have discussed. Okay, so okay, so this is what we already discussed. Okay, so let's presume that the curve is about like this. Okay, sorry about this. Okay, and then I do this with just a tangent one. Okay, and sorry, I just have to bring the x-axis bit down because it shouldn't have been here. Sorry about this, my mistake. Okay, so bring this at least here. So this is your x. Okay, and that's your y. Okay, x-axis and y-axis. Okay, and that's your 0. Okay, so that's your 0, 0 coordinate, and your curve like this. Okay, and that's your tangent. Okay, so this put in the red. Okay, so you know this one. Okay, so and I must write down this here. So this is the relationship we discussed already. So as point B moves closer to point A, okay, the gradient of chord AB gets closer to the gradient of the tangent to the curve at A. Okay, now because we know this, I'm going to draw okay, so let me draw this first before I explain. Okay, so you got here another one, so you got here x, y, this is 0 here. Okay, so let's draw your curve again. Okay, all right, and give point here, this A here. Okay, okay, so we can say this point here xo. Okay, and give this one B, point B here. Okay, so let me just do this one, the distance actually. Okay, so let me label everything, then I will explain to you. So this is your XO and then plus H. Okay, so you just, rather than writing here 1 2 3 4, because I need to explain to you like this, so just remember these things. Okay, what else needs to do? All right, so let's get your code as well to your A to B. Okay, A to B, join that one. Okay, and point B here, let me just give you the coordinates on that one. So, and that is your curve of y equal to, okay, fx. Okay, so point B has coordinates. Okay, so this point B here, what's the coordinate it has? It has your xo plus h, so that is your x. Okay, so you see here that A here, so you'll be going for B. So the B here is your x. Okay, that's the distance, and then that's your x, and then your this distance here, okay, because in y the y would, what the y would be, so this would be your y equal to f. Okay, remember this, so that will be your f. Yeah, and what is your x? Is your xo plus h. Okay, clear that? Okay, so this we got from here, and then with the y we got here y equal to fx, so we got the value of x in there. Okay, now point A has the coordinate. So what point A has the coordinate? That is your point B has a coordinate. Point A has coordinates, so that is your xo here. Okay, and then you got x. Okay, so just to note here that h represents a small change in value. Okay, so here I write down for you here as well that h represents a small change in a value. So just remember that. Okay, value of what? Value of x. Okay, now this is what you will use. We can also write down this as delta dx. We say delta x to represent a small change. Okay, so people write this, or sometimes they write dx as well, delta x. However, this delta x, this is small change in value, and we say this delta x. Okay, so this, so h represents the small change in the value of x. Okay, and we can use delta x to represent this small change, and it's pronounced delta x. Okay, remember that. Now going back in here, you can formalize this approach by letting the x coordinate of A xo and the x coordinate of B here x plus h consider what happened to the gradient of AB as h gets smaller. Okay, so this is what we're gonna discuss. Okay, so if you want, I can write down here as well. So you can formalize the approach by letting the x coordinate of A. Okay, so here what we're talking about here, we can say here that you can formalize this approach. Okay, this approach okay, by what you're gonna do, you're gonna say x. So you're gonna say x coordinate of A, and that will be xo. Okay, and x coordinate of B as xo plus h. Okay, and then consider what happened to the gradient of AB, yeah, as the h get smaller, which means the h will go this side slowly. Okay, right? I hope it's clear, this one. Okay, now before I formalize this, I would like to also just quickly make one of the line. Okay, and that is your AB. Okay, in here. Okay, so I'm bringing this AB here. Okay, your code here. So I bring this one here, just like this, just to make a good understanding of this. A, B. Okay, then right. So remember this one. Now I'm going to start writing now this one here, slowly. So the vertical distance from A to B, vertical distance from A to B is, so let me just write down here, the vertical distance from A to B is f xo plus h, okay, minus f x. Okay, so that's why I got this one here for you. So this distance here, A to here is, let's say, h. Okay, then this one here, that is your vertical one, that is your f x o minus, sorry, plus h. Okay, because it's x, yeah, and that is your from here. Okay, then minus f xo, because you have to minus this distance as well. Okay, right? Because this is your xo, because it's a vertical one, so that what it will give you. Okay, so this distance is this. Okay, and that distance you already got from a, from this point to here is h. So the vertical distance from a to b is this, so remember that, please. Okay, and the horizontal distance is, first you will write this, okay, and then you will minus this, okay, minus xo, okay, and that is your equal to that. Once you open this one, cancel out, cancel, that will be your h. Okay, so that's why you see you got this one here, h. Okay, and that was a reason I drew this line here in red, so that you will understand how did you calculate vertical distance and the horizontal distance. Okay, so I hope this is clear to you. Okay, once this clear, okay, and you understand, that will make a lot of understanding now. So you got your vertical distance here. Okay, so vertical distance got done, this horizontal distance is this. Okay, now if once you have these things, so if I say to you gradient of AB, can you write down that? Yes, obviously you can do that. So now we just have to get the formula, and then you say, just write into that. So the gradient of AB is, okay, so remember I discussed this previously, okay, that when we say the gradient of the tangent, the y2 minus y1 divided by x2 minus x1. Okay, so you remember that one. Okay, when we talk about with the 2 points. Okay, so we discussed that previously. Okay, however, that's not the case here. Okay, that was previously. Okay, so don't get confused with this. Now y2 is different, y1 is different, x2 is different, and x1 is different. Okay, so it's different reading we have here. So what that would be then? So that would be your f xo plus h minus, see, from here we already have that, right? Then we already done this one here, horizontal distance xo plus h minus xo. You could have write here, you can write down this here, okay, because these 2 points you can write down here, or you can simply write h, because we simplified this here. Okay, this cancel out, this is the minus, this cancel out the plus one, you just only have left with h, right? So this is what we got. Okay, now just an understanding of what we have discussed above. Okay, I'm just going to write down, okay, so that makes easier for you to later on to just follow this video. Okay, as h gets smaller, okay, so as the h gets smaller, which means that if the point B comes to here, as the h gets smaller, the gradient of AB gets closer to the gradient of the tangent to the curve at A. Okay, so if you will have any point here, any tangent here, as what we discussed here, this one, okay, that's exactly we're saying here, that as the h gets smaller, the gradient of AB, okay, AB, so AB is your, here is called, gets closer to the gradient of gradient, as get closer to the gradient of the tangent. Okay, don't get confused with that one, of the tangent to the curve at A. Okay, so this is what we're talking about here, because we discussed this one here. So that's your tangent. Okay, so this is what we're talking. So if presume that you have a tangent, doesn't matter which way, this way or that way, whichever, as it's touching A. Okay, and this is what we're talking about here. Okay, so as h gets smaller, the gradient of AB gets closer to the gradient of the curve. Okay, I get closer to the gradient of the tangent to the curve at A. Okay, so what this mean actually? So this means that the gradient of the curve, which means that the gradient of the curve at A is the limit. Remember this, limit of this expression as the value of h tends to, okay, I write down here, tends to 0. Okay, so this is a very important bit here, and that's all the conclusion of your derivative. Okay, so I highlight this one. So what it exactly means? So it says this means that the gradient of the curve at A, okay, this means the gradient of the curve at A is the limit okay, I think I'm missing something here, sorry about this. So okay, this means that the gradient of the curve at A is the limit of this expression as the value of h tends to 0. Okay, tends to 0. Value of h tends to 0. Okay, so what we can do, so we can use this to define the gradient function. Okay, we can use this. Okay, so what you can do, you can use this to define the gradient function. Okay, now here I can use Okay, here, let's go this side. Use this one. So right down here, because we really need a space now. The gradient function or derivative of the curve y equal to fx, yeah, is written as f, so derivative of f to the point x, or dy by dx. So this is what we will use when we do derivation. Okay, now we can write either this way or even this way. Okay, so this can be written whichever way you want to write. Most of the time when we just use, because we use the derivative form, so that's why we just use like this here. But what we say here, this pronounced as the f prime of x, but we don't really use that things. Rather we say read as that the first derivative of x, so it's a derivative of f at the point x. So when I write like this is what I mean. Okay, or dy by dx. Okay, so this is what we get when we get the derivative form. Okay, so this will be used a lot. When I say a lot, mostly all the time. Okay, so just remember that what exactly that means. Okay, therefore now once you understand, as you understand this, so what would we write now with derivative form, this one? Okay, again, so now, so what this f with the okay, so f, what will the derivative of f at the point of x? Okay, so what that would be, the derivation form. Okay, so that will be first, because it's a limit, so the limit will say lim. Okay, so this is what we will use when h is tends to 0. Okay, so this is what we say when the value of h tends to 0. Okay, so it's not exactly 0, but it tends to 0. Okay, remember that. So I write down here for you, I think. Actually, let me write down here. It says okay, so that's I should say notation. Okay, so I haven't finished this one here, so just hold on to this, please. Limit h tends to 0. Okay, that what it means. What means? Means what that means? It means the limit as h tends to 0, you cannot evaluate the expression when h is equal to 0. Okay, this is what I was trying to say to you. Okay, not 0, tends to 0. Okay, so please don't make mistake on that one. So just, that's why you use this, tends to 0. Okay, it's like arrow, h arrow 0, but it hasn't reached there. Okay, just think of that way. It's approaching but not reached there. Okay, so that may be, you'll understand more on that one. But as h gets smaller, the expression gets closer to a fixed or limiting value. Okay, this is very important to understand. Okay, I hope it's clear to that one. I have made it clear to you. Okay, so once you understand this, I'm going to bring you back to this formula again, what I was writing. So this will be written as fx plus h minus fx by h. Okay, because you got this one from here when you were discussing this one here. Okay, so we just use it. Okay, so from here you got that one here. Okay, so what will I write now towards the end? I would say the gradient function can be used to find the gradient of the curve for any value of x. So this is what it is. So the gradient function can be used to find the gradient of the curve for any value of x. Okay, right? So what we will do, using this rule to find the derivative is called differentiating from first principle. Okay, so using this rule we're talking about to find the derivative is called the differentiating from first principle. Okay, right. I hope I made clear to you. Okay, I could have gone and talk about differentiation straight away, taking you to the differentiation and just say this is the formula and this is how we do. But I wanted you to really understand that what is the reason for the differentiation, why we doing it, where is possible to just find the gradient. And this is what you will learn in differentiation. Why I talk about here these 2 points, the chord and this point A and B here, and then moving the B to closer to the A. Then it will make more clear to you. Okay, I hope you understand that one. Now in my next video I won't really discuss much about this one. I will just move on with more examples. Okay, now do me a favor, if you're finding this video informative, please like and subscribe this video. And when you like the surprise, as you know, it motivates me to make more videos. Okay, be sure to click that like button and drop a comments if you have any questions, and we'll do my best to reply back to you, especially these one. If you don't understand anything, if it's something is not clear, I try my best to explain to you this. It's just a beginning of your differentiation. Once you have understanding of that one, it will make very easy for you to understand when it comes to the complex differentiation. Okay, I hope it's clear. Okay, for today, thank you.